Hello, everyone. Welcome to another episode of Solving Chemistry Problems with Mr. Angulo. Today's chemistry problem is a dilution problem, and you can see it on the board here already, right here at the top. It says, to what volume does 15 milliliters of an 0.8 molar NaOH, sodium hydroxide solution, need to be diluted in order to create an 0.16 molar solution? And it's going to be a 0.16 molar solution of the same thing. We're going to assume that the solute is, well, the solute is sodium hydroxide, and we're going to assume that the solvent is water. So these are all aqueous solutions. Before we then go ahead and figure this out, this problem, let me talk about what it means to do this problem and what equation we're going to use. Okay, the equation we're going to use is called the dilution equation, and it goes something like this. M1 times V1, oops, let's see, V1 equals to M2 times V2. Do that one too. And I'll show you how we got it in a little bit, but let's say you had the solution right here in this container. Oh, goodness. Okay, we start off with a certain amount of the solution. And in here, it's your sodium hydroxide solution. This one's 0.8 molar sodium hydroxide. In other words, sodium hydroxide in water. What we're going to do is we're going to go ahead and add some more water in here. And as we add more water, it's going to fill up to a higher level. Okay. And what we want to have eventually happen is we want to end up with a 0.16 molar solution of sodium hydroxide. All right, so just by adding solvent, the water, we're going to add enough so that we get a less concentrated solution. And that works because the equation we had was molarity is equal to moles over volume. So as this number gets bigger, this number is going to get smaller, right? So we start off with a certain number of moles and a certain volume. Let's say this is 15 milliliters, right? That's what the problem says. 15 milliliters, 0.8 molar. If we keep increasing the volume, right, the 15 milliliters gets bigger and bigger and bigger. The moles doesn't change because we're adding solvent. This is moles of solute. Right, so as this stays the same, this gets bigger. Therefore, a number that's constant divided by a bigger and bigger number makes the answer smaller. Okay, and that's what happens with dilution. And what we want to do is we want to find out what is the final volume this needs to get to. How many milliliters this needs to get to until this solution is 0.16 molar. And we're going to use this equation. M1 is the original molarity. V1 is the original volume. M2 is the final molarity, and V2 is the final volume. Okay, in this case, we're going to be looking for the final volume. You could do a problem where you find all of these. Okay. Now, where did this equation come from? This M1 times V1 is equal to M2 times V2 equation. Where did it come from? Real quickly, let me just go ahead and go over that real quick. So if you look at this equation right here, if you solve for N, you get that the molarity is equal to moles N over volume. If you solve for N, you multiply both sides by V to get rid of it. We'll get rid of V on the right side. And so the V's will cancel on the right side, and you'll end up with V times M is equal to N. If we just rearrange that just a little bit, and I'm going to both rewrite and rearrange in one shot, just to save us time, we get that number of moles in any solution is equal to molarity times volume, right? And this makes sense because this is in moles per liter. This is in, if you put this in liters, it'll be moles per liter times liter. The liters will cancel, and that'll leave you with moles. So in the first equation here, the number of moles is m1 times v1. We'll say that this is m1 times v1. So number of moles in the first solution is equal to molarity of the first solution times the volume of the first solution. And in the second equation, in the second solution, I should say, the moles of that solution are the molarity of the second solution times the volume of the second solution. Well, we really haven't changed the moles, right? All we did was add solvent. So we really haven't changed the number of moles. So what that tells us is that N1 is equal to N2 in this equation. When you're diluting, the moles that you began with is equal to the moles that you ended up with. And since N1 is equal to M1 times V1, and N2 is equal to M2 times V2, they are equal to each other, so we can plug in M1 times V1 for N1, M1 times V1 for N1, and M2 times V2 for N2. And so therefore, that's the equation that we get. Okay, so that's the equation we're going to use. All right, so let's go ahead and do this here now. That was all kind of the idea behind it. Let me go ahead and pull our problem out, and let's bring it down a little bit here. And then let's go ahead and get us some space over here so we can use the equations. All right, so let's see what we have here according to this equation. Let me get my pen going here. Is there's going to be an M1, and there's a V1, and there's an M2, and a V2. What are we looking for? We actually have M1, it's 0.80, 0.08, oops. Let me go ahead and 0.80 molar. V1 is 15 milliliters. So the first equation, I mean the first solution, we had a solution that was 0.8 molar and it was 15 milliliters of it. We want our final solution to be 0.16 molar, and we want to find out what volume that has to be. So we're looking for V2 in this equation. So once again, we'll do the M1 times V1 equals to M2 times V2. And I'm just going to plug these guys in. M1 is 0.80 molar. V1 is 15.0 milliliters. That's going to equal to M2, which is 0.16 molar, times V2, which is what we're looking for. So now all we do is solve for V2, and we can go ahead and calculate that, and that's what volume we need to get to. All right, so V2, we want to get it by itself, so we need to divide it both sides by 0.16 molar. So it'll cancel on the right. And if we divided it by 0.16 molar on the right, we need to divide it by 0.16 molar on the left. And we get is that V2 is going to be equal to 0.80 times 15.0 divided by 0.16. It's going to equal to 75.0. Notice that the moles per liter, the molarities, cancel, leaving you with just milliliters as your units. So your answer is in, let me see, do that again, milliliters. And there you go. There is your answer. All right, so this question asked for what the final volume was going to be, which is why we calculated the V2. It was the way that it was asked. One thing to note on this, notice that I used milliliters as your volume. A lot of times, using the molarity equation, molarity is equal to moles over volume, we said that the volume has to be in liters. And it does for that equation. But this equation, you don't have to do that because the molarities will cancel each other out here. So if you turn this to liters, it would work. It would give you the same answer. It would just be in liters. You would, if you want to turn this to liters, you could. You could turn the 15 milliliters into 0.015 liters, and then you'd get an answer of 0.075 liters, which is the same as 75 milliliters if you convert them back. But in this case, you don't have to do that. Okay? So that's how you do that problem. Now, before I go, just a quick note on using this equation. Right now, we learned how to solve for V2, the way the question was asked. It's to what volume? So in other words, what volume? But I could have asked this question in all kinds of different ways. So let me go ahead and just show you kind of how this equation can be, the question can be asked of any of these. I don't know why this sticks here. Sometimes I have to go and undo. Still getting used to using this pen here. M1 times V1 equals to M2 times V2. So I can ask for any of these four variables could be what I asked for. If I ask you what's going to be the final molarity or the final concentration, a solution of 0.5 molar, that is 50 milliliters. What's going to be the final concentration if I dilute this to 220 milliliters? Right? So if I give you the two volumes and I give you the original molarity, I can ask you for the final molarity. Or I can say a solution is diluted to a certain to 75 milliliters, and the concentration ends up being 1.3 molar. If the original solution was 57 milliliters, what was the original concentration? Then you'd have to solve for M1. Or if I told you that the original solution was 0.13 molar, what was my original volume? Okay, then you'd solve for V1. So as you can see, depending on the way the question's asked, any one of these letters could be the unknown. Okay, so I hope that helps for doing your problems. I just want to go ahead and go over how we came up with this equation and just do a sample problem. Okay, see ya next time.